Okay, getting things set up again. First stream in a very, very long time. So, okay. Yeah, it has been way too long. Here's someone coming downstairs. Hi, honey.
Why are you talking to yourself?
I'm testing out my streaming setup.
Oh.
Yes. Anyway, I was going to tear down your smart car radio for the benefit of the internet because I thought it was pretty cool how it was attached. Basically, the faceplate. It unplugs here, and I'm going to basically unscrew it because I think I can make a neat little project case out of the stuff and guts. That's my goal now. I started ripping this apart yesterday before I decided, hey, let me go ahead and record this because it may be interesting, and I saw something neat. So this faceplate basically are four screws, remembering where the cameras are here. 4 screws. There are multiple screws on the faceplate, and of course then it just pops right out. But it is hardwired to the backing board with the display. However, this guy just rips right off. Now this is the factory radio, and so you end up with an on button and the dial, and then the whole thing comes out. So now what's interesting about this, what really cooled me in that, hey, this might be kind of cool, are these are the buttons on it. And each of these, you notice how it's actually kind of like a ring, because in the center of each of those rings, which is going to be very hard to see, is actually a little LED. So this is how they get it to light up on the dash, is basically each button has momentary contact and an LED at the center that lights up when you trigger the button. This part is actually one of those momentary buttons deep in the center of it, and then the outer part is just a rotational resistor. So I thought that was pretty cool. So basically, a rotational potentiometer, I guess. I want to put use a voltmeter across that and see what it's actually returning. If it's resistance, if it's position, how it's doing that. Try and get a little bit more an idea of how this works. Because obviously there's just the button, the LED, and then this rotational potentiometer, and there's only 5 wires coming off this thing. So I'm guessing we've got 4 sensor wires and 1 ground wire, which would be pretty cool. So this part is doesn't have a lot of electronics. Now this part, this huge display, what I'm hoping is that this part is the actual key to the electronics of the display. Now I was trying to get this off earlier. The biggest problem with it is it's soldered on each side to this PCB. So trying to get it off yesterday. I'm either going to ruin this black case if I just force it, or I'm going to have to try and cut it off, which I really don't want to do either. So I was trying to basically melt the solder and pull it off yesterday, and that kind of worked, but it wasn't fantastic. I wasn't thrilled with the results. Otherwise, I'm not really sure what I'm going to do or how I'm going to try and get that off of there, because the solder really does make it impossible to get off. I also don't know what the connectors are like. I'm trying to look at it sideways through, basically through the light on my desk here to see if I can see what's underneath it. And it's just really hard to tell. Because obviously a giant display, that's pretty cool. And getting it for free out of a radio, even better. So, but barring that for now, we'll go ahead and attack this guy. I thought this was neat because essentially, so there's the board on the inside there. All the rest of this is pretty much empty space. There's not much inside it. There's a large heat sink on the back, but it doesn't seem to be attached to anything. It's just kind of held in there. This was the antenna connector. This was the USB and analog input. Obviously a 10 amp fuse, and there's where the connectors for the wiring harness. So, but I think just by having this as a convenient piece, I can put a piece of plexiglass or whatever across the front and have a nice project case for something. I don't know. So I'm going to rip off some of these bits and see what's inside. Maybe there's neat components that we could use on the inside too, which would be kind of cool. Or not. We'll see. For now, I'm just going to take it apart and see what we find. Thank you, Smart Car. Actually, thank you, Helen Smart Car, for providing the free radio to screw with. This was the bane of my parents' existence. Was I like to see how things work, whether or not I knew how they worked. So the obvious way to figure it out was to take it apart. Well, that's not the obvious way to figure it out. It's just a way to figure it out. So it was always interesting trying to put stuff back together again. And I got in trouble several times for doing that, and taking stuff apart that did not go back together in the right way, or at all. Because at some point I was asking, well, how does it work? And anything with screws, well, let me take it apart and see what's inside. Okay, so there's a front plate here, and this top plate, and the top plate wouldn't come off until the front plate was unscrewed, because it has little tabs that were inserted into it. I'm guessing these are like bumper things. Interesting. And here's the inside of a Smart Car radio. So large capacitor, large inductor, nice. Heatsink on a large transistor. What I'm also looking for is what are some pieces that I might be able to use in the future for other projects. In which case it'd be neat to desolder them from the board, pull them off, and use them for something else. I also, if I don't use anything, and I will say, if you do this on your own, be careful, because the capacitors, like these guys, can still retain a charge. It's more true of old TVs and stuff. This kind of thing is probably not too dangerous, but you can basically shock yourself or electrocute yourself or blow up the capacitor by shorting it out. It's called popping a capacitor, if you've ever wondered. I know old radio guys talk about that kind of stuff all the time. You need to be able to keep some of this, like the external hardware, to make sure that it always comes back together the way it was. Yeah. Okay. Well, that's not coming undone very easily. Bit of wax from when I was making wax candles. I had some beeswax and wanted to try something out. It was kind of neat. course, I'm wondering, they had this heatsink over here, but why this large heatsink in the back? What was it doing? Because it's not actually attached to anything that I can see from the front. So I wonder what its purpose was. Or maybe it was RF shielding of some kind. No, it was glued to something. There's heatsink stuff on it. Yeah, so this guy actually has the heat grease all over it. If this were something where I was definitely going to put it all back together, I would pay attention to where things were and which screws went where, and not just throw them all in a giant pile here on the desk.
Are you recording this or live streaming?
I am recording it.
Okay. Good. Edit me out.
Edit you out. I received a request to edit her out. So. Hi, honey.
Hi, handsome.
You don't want to be on the stream?
You said you weren't streaming.
Well, I mean, the YouTube video that I eventually upload.
Yeah. Well, we'll want to be in it. All of that.
Okay. Well, right now it's just your voice, so.
Exactly. Voice is fine. Which is not.
You don't want to show off your dress?
Not yet. It's not done yet.
Not even 10 minutes into the new stream. New house, new stream. Of course, it helps if I'm doing stuff right on camera too, but well, the problem with that guy was it was just really hard to get to, and I don't know why. Okay, so all of the boards are done. Now I've got this twist lock. I don't know what those are called, but essentially it's a piece of metal pushed up to the thing and then twisted sideways so that it's it doesn't pull out. I just got that grease all over me. Ah. Some kind of warranty void sticker. Void that in like 2 seconds. Trash. It also tells me which way this piece of metal is facing, so I know which way to turn this guy. Maybe. Let's see, I gotta rotate it this way. There's another screw way back here behind the inductor. Try to make it so that this can catch it on stream. I think it is just this piece of metal. There we go. Ta-da. I'm guessing that's the amplifier. I wonder what. Heiko low IF tuner. Oh, nice. So really interesting about this, it's got a CL SDA clock lines to find on it. So this might actually use I2C. Let's see if we can get that in really close there. Come on, focus. I know you can autofocus. There we go. That might be something we could actually use that board for something. I'm not sure what though. Because it's an actual. So what I think was interesting about that was, or this whole thing was, it actually basically had a USB input. So there's some kind of intelligence to it that allowed it to function pretty more intelligently than just being a radio. So obviously there was some kind of decoder for USB signals, some kind of audio encoder for the analog input. So it's like where which of the chips do these kind of functions, and are they useful? If not, and so I just in general think that's interesting. So we'll zoom in on the chips as you see them. Of course, I got goo all over them. We'll use my solder to try and clear that off. Some electrical engineer out there is rolling in his grave. And that's the major chip. The smaller daughter chips, that guy. And of course, they can't all be upright at the same time. That guy. So I don't know. I don't know what I would use it for. This inductor's held in place pretty strongly. I might pull off this heatsink. Use it on another project board that needs a heatsink. But for the most part, I'm probably not going to use this for much of anything. I might pull the chips off the board and use them on my chip cup. I have a cup of little computer chips, because, hey, chips. So then, let's put this all back together. Or let's try to. Because I'm now like, gee, I wish I'd have kept where all of these screws went. All the things they screwed into have now disappeared, except for a few of them. Looks like most of the threads are the same on all of them, which is cool. These will all go in my, because it's a smart car from Mercedes, it's probably all metric, which is fine. I don't mind that, actually. I prefer the metric system. I learned it in school, and to me it's a lot more useful and makes a lot more sense. Oh, boo. So this plate that completely surrounds this thing, but there's no way to remove it. Otherwise I would actually stick it back in the hole here. Well, there's no way to remove it without a lot of force. Oh, we can apply force, but we won't today. Nice. Yeah, I like this. I think this will make a nice project case for something. Obviously, it's well ventilated. What I'll do in a lot of cases like that, or with cases like this, I'll take a layer of foam and put it across the bottom, and because we get tons of closed cell foam laying around just from different shipping things, and that way I can use it to line the bottom of the case, or even even more cheaply just cardboard, something like that. How did this go? Well, that was dumb. It's one of those, do I fix it the right way? Because this should have gone on first. But what I can do is just unscrew these top two. I say the top two. The front two screws, and I should be able to lift it up enough to get this crossbar in place. Is it absolutely needed? Probably not. Nice to have, make it look good, sure. I'm obviously not trying to return this to stock or anything. I do want it to look nice, though. Well, do have the potential to look nice in case I needed it in the future for something else. Now, how did this go? There we go. There's little metal tabs on each side. They just need to fit into place. Try these short screws. And I only got like 18 screws left over. Alright, now this one, obviously, tabs into the front and snaps into place. Awesome. I'll leave the Smart logo on there because it's where I got it from. So most of these screws will go into the spare screw bin in case I ever need them again. Otherwise, I'll probably just toss them. But and they might be useful for something. I'm not sure though. As for the board itself, I'm not sure that I'm going to try and... I'm probably going to leave most of those components on there because it's not... I don't think they'd be really useful for anything I would do. I don't know, I've got a spare bin that I just keep old electronics and stuff that I can throw it in. If I see a need for something, I'll keep it. I'll pull it out. But one very nice, well, I say semi-nice project case with mounting holes for whatever. Alright, cool. This is streamed to basically get back into streaming. I haven't done it in a very long time. We just moved to a new place. Work's been really busy, but now it's kind of slacked off just a little, or just enough that I want to, do this on the side, and, keep active at it, and do different projects, because this is the fun stuff, doing electronics. Alright, thanks a lot, and I will see you guys next time. And as I jump to my outro. Alright, I'm actually continuing from yesterday, and no face cam because it locked up at the end of what I was doing. I'm going to try and pull this heatsink off the board here. Unfortunately, so I removed the screw through the MOSFET, but there are a couple of posts that have actually been drilled up through the board. So I'm going to melt the solder around those. first, and then I'm trying to use a solder sucker to pull off the excess there. Yes, I am violating a lot of safety principles. I do not have my glasses on. I do not have a little fan venting. That was my water bottle. Let's see if that worked. Well, at least made them looser. There we go. Okay, not exactly what I wanted, but wonder how they got these things in there. They don't seem to screw out. Yeah, there's no threading on it, so these look like they're compression fit somehow. So. Ooh, well. Snippy snip time. Handy hint, always do that away from your face, because it's a lot of pressure on a small piece of metal will make it just jet right there, right off of there. So now I have a heat sink for a MOSFET. Can be used in other projects. Do I want the MOSFET itself? Not sure on that one. I might just go back into the bid bucket. And I thought about doing this board again since it is an RF board, but I'm still probably going to save that because essentially it's soldered in that long row of connectors, and I'm a little lazy for that, so skip it. That's enough of that one. You can go off to the side. Now this guy, actually, I kept playing with it more yesterday. So this thing, I checked the, so let's see if this will work. Turn off the solder. So of the three connectors that are here, the first one is power on, and then two other connectors after that. However, what I notice is the middle one, well, it does have solder. So anyway, what I did was I ran the resistance on all three of them. So basically just checking to see how it measures. I don't have any voltage across it. But seeing when I spun it, what it did. And it registers a resistance, or a change in resistance occasionally on the single ohm scale, or on a 200 ohm scale, but only as it changes. And at some points it just has 1 or -1, meaning it's off the scale. So I think this is actually a lot like the way an iPad, or basically what it would have is, instead of a series of contacts, we'll have a series of contacts at an angle, so that as it spins, what you're getting is the difference in resistance, not an absolute resistance like you would with a normal potentiometer. So I'm still not sure exactly how I would use this for, or how I would use this, or what I would use it for, or where it would be good to use. So it's just kind of one of those things where I don't know what I'm going to do with it. I still want to keep it because it kind of looks cool and it makes a neat noise. So I haven't touched any of these buttons yet. Unsoldering these would also be really difficult. So I was looking at the bottom of the board here. They're obviously surface mount components, which is kind of cool, but at the same time there's 6 connectors, 3 on each side of all of them. So it'd just be a pain to get them out of there, but at the same time, keep them in there. So now, what I did do is I did the same thing I did on the heatsink, where I pulled off the solder using the solder sucker, and I was able to pull this guy up, and I'm just going to rip this off of here. Extra piece of metal hanging out, but so now I have this board. So let me see if I can bend the plate out of there. Now we now have a display. So then, looking at this display, the top here, I'm seeing V out, RT2, RT1, SVD2, ground, and 3 volts. So I think this might be something we can try and control. It doesn't look like it does I²C, or at least I'm not seeing anything labeled like that in a clock or an SDC. But this might be something we could try and, now that we can see the part number, figure out what the controller is, what the controller chip is, and then look up the data sheet for it to figure out, how we could control it. Because, like I say, it is a nice large display that should give us multiple values, but it's probably going to be a pain to figure out what the signals are, but still, totally worth it to try. And Varitronics is the name of it, so zoom in close on that one. Yeah, so cool. As a follow-up to yesterday's, I thought this would be good to do, to show off. And of course my screen just blanked, because God knows it would be too easy for it not to. Spare parts bin. Okay. Well, that's all I wanted to do. I'm actually going to splice this in with the other video towards the end, and basically the rest of it is Googling for part numbers. So, thank you all.